Welcome to E-Pathsala. I am Deepa Satish, Assistant Professor in Nutrition. In this module, we are going to see about extruders. Let us see first introduction. Extrusion technology is gaining increasing popularity in the global agro-food processing industry, particularly in the food and feed sectors. Extrusion cooking technologies are used for cereal and protein processing in food. Today, their processing functions may include conveying, mixing, sharing, separation, heating or cooling, shaping, co-extrusion, venting, volatiles and moisture, flavor generation, encapsulation and sterilization. They can be relatively low temperatures as with pasta, spaghetti, noodles, etc. Keeping in this view, the present article describes the detail about the types of extruders, physiochemical changes occurring during extrusion process and recent developments in food industry regarding extrusion process. Today's lifestyles are vastly different from those of the past due to increasing in number of single-person households, and gender equality rights have led to changes in food preparation and consumption habits. That is, modernization and globalization made people's very hurry and no time to cook their own food, especially during morning. A positive outcome of this has been made rapid advances in food technology. Not only these factors and also the increasing demand for non-meat, high-protein products made a highly profitable ventures in the food industry. Nowadays, consumers do choice for nutritionally rich therapeutic benefits and for attractiveness, especially in case of baby foods. Thus, to obtain above mentioned designer food extrusion technology is used. Let's see the term what is food extrusion. Food extrusion is defined as a process in which material is pushed through an orifice or a die of a given shape. The pushing force is applied using a piston or a screw. In food applications, screw extrusion is predominant. The below diagram shows you the schematic diagram of typical single screw food extruder. Extrusion cooking technology was invented in the 1940s by the Adams Company to manufacture snack foods from maize grids. It is derived from the earlier extrusion technologies used to form pasta at temperatures of 70 to 80 degrees Celsius. These processes involved the conveying, mixing and compressing of moist wheat semolina to form dough and to extrude it as well-defined shapes. Extruders were developed in the 1870s to manufacture sausages. Application of the single screw extruder evolved during the 1930s when it was used to mix semolina flour and water to make a pasta products. It was also used in the process of making ready to eat, that is RTE foods. Cereals to shape hard pre-cooked dough. In both of these applications, the level of shear rate was low. During the late 1930s and 1940s, directly expanded corn kernels were made using extruders which were characterized by extremely high shear rates. The first patent of an application of twin screw extrusion technology was filed in mid-1950s. Since then, the application of extrusion technology has widened and grown dramatically. If you see about the history of extruders, historically one can trace the use of a screw as a conveying device to the Greek philosopher Archimedes, who used a single screw in a cylindrical open channel to pump water uphill. Today, extruder consists of one or more screws encased in a metal barrel attached to a drive motor. A hopper at one end is used to feed raw materials, while a die on the other gives shape to the product. The below table showing the history of the extruders. So let us see what is extruders first. The extruders are the machine which forces the mix through the die is an extruder, and the mix is known as the extrudate. The extruder consists of a large rotating screw tightly fitting within a stationary barrel at the end of which is the die. Extruders come in several designs dependent upon their application. Some extruders are designed simply to convey the raw materials, while others are designed to mix and knead them. Most, however, are designed to impart mechanical and thermal energy to the raw materials to bring about desired physiochemical changes. Extruders can be broadly categorized on the basis of method of operation, that is cold extruders and hot extruders, which is commonly used in extrusion cooking, and method of construction is single or twin screw extruders. The most commonly used extruders are single and twin screw. Extruders with more than 2 screws have been used in the plastics industry but not in the food processing. The below diagram shows you the different parts of the extruders. An extruder is composed of 5 main parts, that is preconditioning system, number 2 feeding system, number 3 screw or worm, number 4 barrel, number 5 die and the cutting mechanism. Also, they can vary with respect to screw, barrel and die configuration. The selection of each of these items will depend upon the raw material used and final product desired. Preconditioning. Preconditioning with steam or water has always been an important part of the extrusion process. Preconditioning is not applied to all extrusion process. In general, this step applied when moisture contents around 20 to 30% and long residence times of the material are used. Preconditioning favors uniform particle hydration, reduces retention time within the extruder and increases throughput, increasing the life of the equipment due to the reduction in the wearing of barrel and screw components, also reducing the cost of energy involved in the process. Feeding system. It is necessary to guarantee a constant and non-interrupted feeding of the raw material into the extruder for an efficient and uniform functioning of the extrusion process. Screw. The screw of the extruder is certainly its most important component, not only to determine cooking degree, gelatinization and dextrinization of starch and protein denaturation, but also to ensure the final product quality. Screws can be monopiece composed of unique piece or multi-piece which is composed of various elements. Screw elements can vary in number and shapes. Each segment is designed for a specific purpose. Some elements only convey raw or preconditioned material into the extruder barrel, while other segments compress and degas the feedstock. Others must promote kneading, backflow and shear. Barrel or sleeves. The barrel is divided into feeding, kneading and the sleeves surrounding the screw can be solid, but they are often jacketed to permit circulating steam or superheated oil for heating or water or air for cooling, thus enabling the precise adjustment of the temperature in the various zones of the extruder. Next is die. The die presents two main functions: gives shape to the final product and promote resistance to material flow within the extruder, permitting an increase in internal pressure. The die can present various designs and number of orifices. And other one is cutting mechanism. The cutting mechanism must permit obtaining final products with uniform size. Product size is determined by the rotation speed of the cutting blades. This mechanism can be horizontal or vertical. Let us see for single screws extruder. Single screw extruders contain a single rotating screw in a metal barrel and come in a varying patterns. The most commonly used single screw have a constant pitch. The raw materials are fed in a granular form located in the feed section. The rotating action of screw conveys the material to the transition section. In the transition section, the screw channel becomes shallower and the material is compacted. A major portion of mechanical energy is dissipated in this section, which results in a rise in temperature of the material. Starch becomes gelatinized and the material becomes more cohesive. It is transported further by metering section and pushed through the die opening. The barrels of single screw extruders usually have helical or axial grooves on inner surfaces. This helps to convey and mix the material more effectively. Next, we will see about twin screw extruder. Twin screw extruders are composed of two axes that rotate inside a single barrel. Usually, the internal surface of the barrel twin screw extruder is smooth. However, this type of extruder is little used in the food industry, even though they present more efficient displacement properties. When the material enters the barrel, the ingredients are thoroughly mixed before further processing in the other zones of the extruder. In this initial step, the screw is designed with a large screw channel department to provide enough space between the root of the screw and the barrel for sufficient mixing to take place, and often the screws are reverse threaded to permit intensive mixing and longer residence times before delivery. In the exit zone, the diameter of the root increases rapidly while the channel depth becomes shallower in order to provide material cooking, thus increasing the pressure applied to the product and the starchy content of the food gelatinized proteinous material is denatured. The below diagram shows you the typical twin screw extrusion facility, and also the other diagram gives you differences between the single and twin screw extruder, which is given in the table. Food extrusion is high temperature short time, that is H3H3 process. Figure 3 shows you how comparison of the food extrusion process with other processes on a diagram with temperature and residence times as axis. It can be seen that during extrusion, the food material may be exposed to temperatures as high as 200 degrees Celsius. However, the exposure to such high temperature lasts only 1 to 10 seconds. In a typical corn cooker, the operating temperature is about 100 degrees Celsius and exposure time is about an hour. Figure 4 shows a flow diagram of the production of cornflakes using the conventional process and using an extruder. One can see that several steps that are used in conventional cooking are eliminated by using an extruder. Though there are some differences in the products obtained from the two processes shown in figure 5, several manufacturers have adopted the extrusion process because of the advantages discussed earlier. Let us see physiochemical changes during the extrusion. The most used raw materials in the extrusion process are starch and protein based materials. The structure of this extruded products may be formed from starch or protein polymers. Most products such as breakfast cereals, snacks and biscuits are formed from starch, while protein is used to produce products that have meat like characteristic and that are used either as full or partial replacements for meat in ready meals, dried foods and many pet products. Major changes occur during extrusion process are changes in starch, changes in protein, changes in lipids and changes in fiber. Let us see about the raw materials. In general, the chemical or physiochemical changes in biopolymers that can occur during extrusion cooking include binding, cleavage, loss of native conformation, fragmentation, recombination and thermal degradation. The structure of an extruded product is created by forming a fluid melt from a polymer and blowing bubbles of water vapor into the fluid to form a foam. The bubbles rapidly expand as the superheated water is released very quickly at atmospheric pressure. Let us see the changes in starches. The major difference between this extrusion processing and conventional food processing is that the former starch gelatinization occurs at much lower moisture content, that is 12 to 22%. Once inside extruder and at the relatively high temperature, the starch granules melt and become soft, besides changing their structure that is compressed to a flattened form. The application of the heat, the action of shear on the starch granule and water content destroy the organized molecule structure, also resulting in molecular hydrolysis of the material. The starch polymers are then dispersed and degraded to form a continuous fluid melt. The fluid polymer continuum retains water vapor bubbles and stretches during extruded expansion until rupture of the cell structure. The starch polymer cell walls recoil and stiffen as they cool to stabilize the extrude structure. Finally, the starch polymer becomes glassy as moisture is removed, forming a hard, brittle structure. Changes in protein. Proteins are biopolymers with a great number of chemical groups when compared to polysaccharides and are therefore more reactive and undergo many changes during the extrusion process, with the most important being degeneration. During the extrusion, disulfide bonds are broken and may reform. Electrostatic and hydrophobic interactions favor the formation of insoluble aggregates. The creation of new peptide bonds during extrusion is controversial. High molecular weight proteins can dissociate into smaller subunits. Enzymes, also proteins, lose their activity after being submitted to the extrusion process due to high temperature and shear. Changes in lipids. Fats and oils can be described as lipids. Lipids have powerful influence in extrusion cooking processes by acting lubricants because they reduce the friction between particles in the mix and between the screw and barrel surfaces and the fluid melt. Changes in fiber. Research has shown that cooking fibers by extrusion can produce changes in their structural characteristic and physiochemical properties, within the main effect being redistribution of insoluble fiber to soluble fiber. This effect would be the result of the rupture of covalent and non-covalent bonds between the carbohydrates and proteins associated to the fiber, resulting in the smaller molecular fragments that would be more soluble. Influence of extrusion cooking on moisture and temperature. In the extrusion process of expanded products with low moisture, the expansion of the final product is inversely related to the moisture of the raw material and directly related to the increase in extrusion temperature. However, the effect of moisture is more significant. In high moisture extruders, expansion occurs when the product exits the die, but the structure collapses before the necessary cooling, resulting in the dense and hard product. Another important parameter for extruded expansion is process temperature. Products do not expand if the temperature does not reach 100 degrees Celsius. Expansion increases with the increase in the temperature when moisture content of the material is close to 20% due to lower viscosity, permitting a more rapid expansion of the molten mass or due to an increase in water vapor pressure. At low extrusion temperature, expansion is reduced because starch is not completely molten. Radial expansion degree is proportional to temperature up to a certain value, decreasing at much higher temperature. The reduction of expansion at very high temperature is attributed to an increase in detexturization, weakening the starch structure. Let us see the influence of extrusion cooking on various parameters. There are three main factors of extruded product on consumer view are product quality, nutritional quality, microbiological quality. First, influence on product quality. Extrusion cooking has an important influence on product quality, emphasizing features like expansion, texture, shelf life, color and flavor. Products obtained with the high temperature and short extrusion process times normally present a porous open structures what confirms to them a crunchy structure. Color in extruded products is influenced by temperature, raw material composition, residence time and pressure and shear force. Effect of extrusion on nutritional quality. The effects of extrusion cooking on nutritional quality are ambiguous. Benefits include destruction of anti-nutritional factors, gelatinization of starch, increased soluble dietary fiber and reduction of lipid oxidation. Starch digestibility is largely dependent on complete gelatinization. High starch digestibility is essential for specialized nutritional foods such as infant and weaning foods. Creation of resistant starch by extrusion may have value in reduced calorie products. The nutritional value of vegetable protein is generally enhanced by mild extrusion cooking conditions due to the increase in the digestibility, probably a result of protein regeneration and the inactivation of enzyme inhibitors present in raw materials by the exposure of new active sites for enzyme attack. Influence on microbiological quality. One of the most important consumer requirement is the microbiological safety of food products. Most conventional extruded products such as snack foods and breakfast cereals are safe to eat because the raw materials are subjected to high temperatures that is higher than 130 degrees Celsius and the water activity temperatures that is 0.1 to 0.04 of the product is low because the product is dry to a moisture content of less than 5%. Although it is well known that the most vegetative organism, yeast and molds are destroyed under typical extrusion conditions that is 55 to 145 degrees Celsius. So let us see recent developments in dairy, breakfast cereal and pet food industry. Extruders permit the production of many food of nutritional importance. The ability of extruders to blend diverse ingredients to make novel foods. Some of the recent advances under dairy, breakfast cereal and pet foods are discussed further. Extrusion in dairy industry. Milk protein possesses health benefits and desirable functional properties, and protein is subjected for mechanical shear. So considerable changes in the molecular structure of the protein is seen. These changes leads to formation of new protein based product known as texturization. The texturization stretches and shears the protein to form a new fiber bundle like structures which withstands hydration, cooking and other procedures. Below table shows you the recent developments in the dairy industry. Extrusion for breakfast cereals. Basic process of making breakfast cereals include flaking, oven, gun puffing, baking, shredding and direct expansion, which convert raw and dense grains into friable, crunchy or chewable products with a density of 0.6 to 1.6 kg per 100 centimeters cubic. But the extrusion process combines all the above processes and presents advantages over the conventional processes. The diagram shows you the extrusion of ready to eat cereals. Meat extrusion in meat analogs. Increase in vegetarians lead to a preparation of protein incorporated meat extenders and meat analogs which can be obtained from extrusion process. Vegetable protein possesses a characteristic appearance and structure similar to fibrillary structure of meat. Thus, meat extenders are obtained from the thermoplastic extrusion at moisture contents 20 to 30% and meat analogs are obtained at high moisture contents 50 to 70%. The main vegetable proteins used to prepare meat analogs are legumes, soybean, common beans and peas. The cereals which contain wheat proteins respond for gluten network. Pet foods and animal feeds. Extrusion is not only used to prepare food for humans but also used to prepare semi-moist and dry expanded pet foods, aquatic food and foods for laboratory animals, whereas dog and cat foods are directly extruded and dried. Feed for ornamental fish, high grade complete feeds to maintaining the health. Foods for exotic species in aquariums can also be made from extrusion process. This permits better utilization of available cereal grains, vegetable and animal proteins. Let us conclude. Extrusion cooking, because of its low cost and continuous processing capability, is a popular means of modifying the functional characteristic of cereal grains. This high temperature and short time processing technique is capable of thoroughly gelatinizing the starch even at low moisture levels. Earlier we have seen extruders and extrusion process. Extruders of two types we have seen, that is single screw and twin screw extruders. Extruders permit the production of many foods of nutritional importance. The ability of extruders to blend diverse ingredients in novel foods can be exploited in the development of functional foods. Traditional snacks or breakfast cereals can be enhanced by the addition of extra fiber or whole grain flour as ingredients. During extrusion, transformed into palatable cereal based products that also promote beneficial physiological effects. Extrusion enables mass production of food via a continuous efficient system that ensures uniformity of the final product. Food products manufactured using extrusion usually have a high starch content. These include some pasta, breads, many breakfast cereals and ready to eat snacks, confectionery, pre-made cookie dough, some baby foods, full fat soy textured vegetable protein, some beverages and dry and semi-moist pet foods. Consumers are discriminating. Consumers want healthy nutrition. Consumers want fair prices. Rightly so. Extrusion systems meet the current constantly changing requirements flexibly, efficiently and economically.